Alright guys, welcome to another video. This video is all about perspective training and understanding the scene. Okay, so let's get to it. I quickly want to go through some of these grids that we're going to use, how to set them up, and then I'm going to show you some side views and top views to better understand where all these points come from. And yes, let's label a few things. Okay, so the first thing that we want to do when we do a drawing or we want to imitate photography is we need a few things. Alright, we need to know where the, if we, for instance, like say I took a photo of something and you would like to take the same photo of the same object. So you need to know where did I stand, what was my position, what camera did I use, and all these types of information. Okay, so this is what I'm going to show you guys today. So we need grids to help us draw in perspective and correctly draw into perspective and into depth to create the illusion of 3D on a 2D plane, like the paper. So these are the grids that we can work with. Some of them are easy, some of them are a little bit difficult to work with, but with practice you will get better and you will actually know how to identify these grids and to when to apply them and how best to apply them. Okay, so the first kind of grids that we look at is your orthographic views, okay, and your basic views. Okay, so that's like a front plane, the top plane, and the side view. These are simple because there's only verticals and horizontal lines. There's no convergence into depth. Alright, okay, for all these. So it's easy to understand and it's easy to add to these grids, right? And it's easy to actually think about dimensions and measure things and all those things. We don't have to think about things converging into space and then what the conversions are and all the measurements and things that goes with that. Okay, so this is a basic rectangle, okay, and you can see I've set up a front view. So this is the front, A, B, C, D. Okay, you've got a vertical and you've got a horizontal line, and then this point where they intersect each other is a point or intersection. Alright, so another orthographic view is the top. Okay, so I'm just imagining this box and how it would look from the front and perhaps the top. They will definitely share the same width. Okay, so the depth is something new, and then the side view. Okay, so this object will share the same height, and then the side view will show us the distance into space from the side. So if I want to add something to this grid, it's quite easy. Okay, so what I do is I can drop in verticals, alright, and I can drop in horizontals wherever I like, and I can subdivide as many times as I want. Alright, so I can actually draw verticals there and there to find a little box here. Okay, let's say on the front view I'm going to extend the little box this side. So now you can see I'm starting to build this thing in space. Okay, so this is the front view. So this is, from the top I can actually add things as well. I can cut out something if I wanted to. Let's say I want to add a section here. So the thing that I keep in mind is the verticals and the horizontal lines. Okay, I want to stay parallel to them and I want to use them to guide me. Okay. Same here, you can drop in horizontal lines and vertical lines wherever you want them. Okay. Side view, let's add something. Let's say there's a little extension at the back. Okay, so BD, this is obviously then looking from the front, the side. And these things you have to define for yourself. You have to use a little bit imagination that comes with the job. And let's add something to the top. Okay, so what I didn't do was do all the changes on the same thing. So let's say this is different rectangles. If this was the same rectangle, like I intended it to be, but then for the side view, this at the top, or the front view, this little section would be added. Okay, side at the back, I won't see this on the front. The top view, this would be added. So let's say that was a cutout, so I won't see it here, and I won't see this there. And to the top I extended this, so from the front, let's add that. Let's rather add that. So from the top view I came out and added this section, and you will definitely see this from the front view. Okay, nice storm going on here. Alright, so from the side view, perhaps this was the other side, but let's just say that section was there. Okay, so it's easy to add and design on these grids, okay, because there's no convergence or depth that we need to think about. So this brings us to the next few grids that we want to use, and this is the 1-point perspective, 2-point and 3-point perspective. And these grids are grids that we use to actually create the illusion of 3D on a 2D surface. Okay, but all these grids have their advantages and disadvantages, and think of these grids as tools that you can use. Okay, so if you want to just show something, let's say you want to show an object or environment or something like that, then you would choose one of these grids, and one of these grids will actually suit the subject matter a little bit better than the other one. Okay, so getting to know these grids is very important. Okay, so the thing that you have to keep in mind, okay, at all times is the physical parallel lines. Okay, the things that the box are made of, they are parallel. It's a box, it's a cube, it's man-made, the edges are perpendicular to each other. It's not built intentionally skew. So we are focusing, because we work with the grids, on physical parallel lines. Okay, even on this grid, I didn't draw in no verticals like this or that. I kept it parallel to each other and straight. Okay, so this is to guide us, and this is the way grids work. Okay, precise. Okay, so all physical parallel lines converge to a common vanishing point. Okay, so this is the thing with perspective grids. There are vanishing points, and this helps us to actually draw in 3D space. Okay, so where does this vanishing points come from? Again, what are they? So on a 1-point perspective, okay, it's like the name says, there's one vanishing point, okay, to think about. Okay, and this makes it easier because there's only one vanishing point, and this vanishing point is on a horizontal line, or on the horizon line. Alright. Okay, 2-point perspective, there's going to be 2 vanishing points. Alright. And a 3-point perspective, it's actually a 2-point perspective, but there's an added point above the horizontal line somewhere and below the horizontal line, which creates the 3rd point. Okay, so I'm going to show you where all these things come from. Okay, we're going to name a few things, label a few things, and then I'm going to show you the effect of these. Alright, so in order for me to show you guys how this works, I'm going to use an orthographic view, a side view actually, to better explain my point. Alright, okay, so I'm going to take this rectangle, this one that I did on the left, and I'm going to put a viewer or a photographer or a camera in front of this box, okay, right in front of this box. So this view, this guy is standing perpendicular to this subject matter, okay, so this is 90 degrees. Okay, so this is the top view. So I'm going to place a camera somewhere here, and I'm going to look at this whole scene from the side now. Okay, so let's talk about terminology for a while. So the first thing I would need is I would obviously need a ground plane. Okay, because we're emulating photography here, or this guy standing there, so he's obviously on some kind of surface. And the ground plane is the physical surface that the camera was on when the photo was taken, or where the observer stood when he was watching everything, or where he is standing actually. Okay, so ground plane, okay. Also the position and the place, it's connected to the ground plane, like is it on the beach, is it on the street, is it on a building, wherever, okay. So now let's say this is the ground plane. Okay, so this is, I'm just going to show you variations of the ground plane. So let's say we've got this guy now. Alright. Okay, and he's standing on this ground plane, and his eyes is the station point. Okay, this is the next term that we're going to use. So we've got the ground plane and we've got the station point. Okay, if this was the camera, same thing, station point. And this is just the point in space. Okay, so the thing that's important to remember with all these terminology and things, think about everything that I'm going to show you now as being part of a web. Alright, if you pull on one of these corners, or if you delete one of these points or mess with this grid, this whole thing rattles and everything moves. So everything is influenced by everything. Like the station point is connected to the ground plane, and this gives us the height of the camera. Okay, obviously you can think about this guy as, oh, okay, I'm going to talk about the camera and the eye. I'm so used to changing them, but it's the same thing. It's actually, alright. And this station point is now connected to the line of sight. Alright. So the line of sight is this guy looking in the direction of the object. It's also the viewing direction. So line of sight. Okay. The rain is nice. Alright, so okay, the line of sight. And this is connected to the station point. The station point is connected to the ground plane. Okay, and so on and so forth. And I'll show you things with the line of sight now. So let's say this guy, he's looking at this box. Okay, so in top view you can see it's a little bit longer, so the front is it's a little bit narrower. Okay, and he's looking through a picture plane. Right. So let me just quickly move this a little bit out of the way. Okay, so the picture plane is also very important, because this is where perspective drawing is happening actually. Okay, so now let's add our picture plane here. Okay, so the picture plane is usually, if you think about a piece of glass in front of you, and you would look through the glass, and let's say you're looking at a garden or a building or something, and when you start to draw on the glass the outlines of what you see through it, that is called perspective drawing. Okay, so the picture plane is actually the place where the image gets recorded. Everything around it and in front of it and through it is actually where we are trying to understand the scene. Okay, so the picture plane is usually this bounding box where we draw on. Okay, so this defines also how much we see. So if you've got a square picture plane, then the setup would be square. Okay, so you can decide on the picture plane. Okay, but when we explain these terminologies and things, the picture plane is actually it's actually very useful. Alright, so okay, so I've added the picture plane. So now let's just look at a few things here. I'm going to record, this is my first picture plane, second and third. I'm going to record some of these things that this guy is seeing. So I want to look through his eyes. alright, and see what he's actually seeing, and I want to recreate this on our picture planes. Okay, so I want to actually take my camera, go to the spot where he stood, and place it in the same position, same height, and then take this, and with the same lens or perspective grid, I want to take the same shot. Alright, so let's just see that I cover all these things. Okay, also always keep this physical parallel common point in mind. Alright, okay, so let's record something on this picture plane. Okay, so the next thing that we're going to see is if I connect this corner to the eye or the lens or whatever, these lines are called vision rays. Okay. So let's say, for instance, this is point A, B, and C. You can see if you follow this back that point C gets recorded on here. Point A, it's a spot there, and point B, it's just above that. Okay. It's actually, it seems like it's the same spot. Let's just make sure. Okay, going through the same spot. It's because it's closed. Okay, so now let's see how this works. Okay, so the line of sight also gets recorded on this picture plane, so it goes through there. So what we do is we transfer these points to our image. Okay, so the line of sight goes through the picture plane, and this is in fact a 3D setup. So this is the line of sight going through the picture plane, but now I'm going to draw this picture plane, and I'm going to use this line, and I'm going to call this line, okay, so it's just a little, there's halfway, a little bit up. I'm going to call this line the horizontal line. So on the picture plane, the line of sight is represented by this horizon line. And this line is very important because this is connected to the station point, and the station point gives us the height of the camera. Alright, okay. So now I've got my horizon line set up. This is the height of the camera. Okay. So let's put in these points. So I'm going to say point C is down here, then a little bit up is point B, and then just above that is point B. And what I'm going to do is I'm going to look at this view and see, okay, the viewer is actually standing right in front of this object, okay, perpendicular. So I'm going to put a vanishing point right in the center of my page, okay, and then I'm going to start with this C, okay. So I know if I stand and I look through this guy's eyes, this is a box. You can see actually this is a box. So now I'm just going to estimate the same kind of proportional box. Okay, so this is a little bit more square. Okay, okay, so this is this box. So I'm going to do this box. All right. Let's make it a little bit thinner. Okay, so this is this point connected. Then a little bit up. So now I'm just actually going to start with the first rectangle shape of my box that I'm looking at. And already you can see that you can imagine that this guy is looking at this box. Okay, but now we want to see the depth. We don't want to have an orthographic view. We want to emulate 3D now. And this is where all physical parallel lines converge to a common vanishing point. So this is the vanishing point. This is our rectangle, the first one. Now all physical lines need to go back to that point. Okay, so why? Okay, so let's quickly just understand the vanishing point. So I'm going to do the same setup, just quickly, and I'm going to have a ground plane. Okay, so this, just make some. So I'm going to have a ground plane. Okay, I'm going to have a station point. This is the camera or the lens. I'm not going to draw a picture now. And I've got my line of sight. and the height of the camera. Okay. So now let's think about this vanishing point for a while and the horizon line. Okay. So in the first grid, we only had a vertical and we had a horizontal line. Okay. So now we want to go into depth. We want to do something here, but we need some structure, we need some rules, or we don't know what. So let's say I want to add the second line and I don't have anything. I'm not sure actually how this works. How do I create this 3D effect? All right. So this line is the line that goes into space, into the depth of the picture. So this is actually this distance going back. Okay, that the depth of this rectangle. So I'm going to take, this is just the test side of the picture plane, important. So what I'm going to do is I'm going to create a point here. I'm going to draw a line that goes into depth, alright? And I'm going to make another line, or another point just here. And I'm going to connect this to what the viewer might see. Right. So I can see A gets recorded on here and B gets recorded on here. Okay, that's awesome. So I'm going to do small picture plane here. Okay, so this is the picture plane. Looking through it now. And I can see the height is somewhere here in the middle. I'm just going to put it a little bit higher. And the vanishing, well, okay, so so somewhere here, line A, or point A, was recorded. Okay, a little bit above that, straight up, point B was recorded. Okay, and I'm going to connect these. Alright, so let's take this line and we extend it even more. Okay, so now my paper is running out, but I'm going to make a point C there, connect this back, and I can see that it was getting a little bit higher. So this is point C. So point C is somewhere there now. Okay, let's connect this further. So now I've run out of paper, but what will happen eventually is these points will go up and up and up the further I go into the space, and eventually reach this point on the horizon line, because this is the line of sight, also the horizon line, and it will vanish. Alright, okay, on the picture plane. So this is moving up the whole time, and eventually the end of this line will vanish to a point on this horizon line. So this is the vanishing point. Okay, so let's do another test. I'm going to add a line just below this, directly below this, A, B, C. Let's do this. This is D now, but I'm going to come a little bit forward now. I'm going to create a point D here. Don't worry about the picture plane. You can always just move this a little bit up to frame the image. Okay, so there's D is way below A. So straight down is point A, B, C, point D. And now I'm going to draw a line and create a point E. Let's see where this connects. Okay, so it's just above A, so about there. Okay, so now if you can imagine these two lines, okay, so in this image they are parallel to each other, and still it's going up, up, up to the same vanishing point. Okay, so let's go into a side view quickly to see if this is true. So looking at my object, the box, straight on, this is the guy standing there, station point, picture plane. Now what I'm going to do, because in the side view I can't go to the side, so let's say line AB is this, AB, and now I'm going to draw a parallel line to this side. Okay, so this is the picture plane, this is AB, so AB, so I'm just going to say EF. And then what I'm going to do is I'm going to go from this point to this section, and there's a point there that gets recorded, and let's say this point goes there, and I can see it's a little bit closer. So we've got a left and then the right. So there's a distance, there's a distance. So now if I put this on here, so let's say from A I was going to there, and now I just have to come to the right. But what essentially will happen is this will go to the right all the way until it intersects this vanishing point. So I can actually just put in the long distance and connect it back to the vanishing point. And all these points that I will find will be on this line somewhere. But the beginning and the end will always converge to this vanishing point. Okay. So now if I put a point here, take it back to the vanishing point, I can actually start putting points on here, divide this and this. But I know that these lines are parallel to each other. Okay, so this is very technical, but if you can wrap your head around this, this is powerful information that you have to use to manipulate these images and use it to your advantage. Okay, so this is the vanishing point now. Okay, so based on all that we just did, is I'm going to take these lines and I'm going to extend them to the vanishing point to create my box. Okay, the depth, I'm just going to make an estimate, and because these lines are parallel, I need to stay within that confinement of the converging lines. So there, I'm going to put it there at the back, and voila, the grid helped me to establish this correct distance into space. And based on what I'm seeing, so this guy, you can see the line of sight, it's this distance, it's a little bit above the object, and we can see the top looking down, and this is what's happening here. Alright, so that's the first image recorded through this lens. So now let's start moving these things around. Okay, let's start playing with the image and try to design and invent, okay, or move the viewer around. So I'm going to focus on 1-point perspective for now, but all of these things we can take into 2-point perspective. This is just to keep the video short. Okay, so, and I'm going to show you the difference between the 2-point and 3-point, so don't worry. So now, the next thing what I want to do is I'm going to move the horizon line a little bit. Okay, so I'm going to move it down. So the next image, what I'm going to do is just move it there. Okay, so the horizon line, I moved. So what happened? Think of this web now. Okay, so the horizon line, which is essentially the line of sight, which is connected to the station point and has something to do with the height of the camera, has moved down now. All right, and it has moved considerably, well, quite a distance. So this guy, the camera, dropped, and let's say he's looking into the object now. Okay, so now he's actually crouching or something. Okay, looking forward. The line of sight in the first two grids, 1-point perspective and 2-point perspective, it's very important that they stay parallel to the ground plane. All right, I'll show you guys just now why. Okay, but let's drop this. Okay, so nothing else changed. Okay, the vanishing point still, it's the same position. This guy didn't move left or right, or the only thing that he did was crouch down. So we can see this in the side view. It went down, the line of sight went down, and essentially the horizontal line went down. Okay, but the vanishing point still in the same place. Okay, this has to do with him moving left or right, still there in the center. Okay, and the shape of the box still the same, so I'm going to draw the shape of the box now. Okay, actually the picture plane, it moves with the viewer. Okay, so think of this as the viewer's head and his line of sight, and this picture plane always stays perpendicular to the viewer. So if he's looking this side, this picture plane is always going to be perpendicular to this guy. Alright. So the picture plane also shifted down a little bit, okay, so that we can actually frame the shot. That's what happened. So I'm just going to extend this a little bit down so that I can actually get the line of sight to hit the object around about in that area. So this is the horizon line, so I'm just going to add this section to the top and then add in the rest of my image. Okay, so ignore this line now because this was the previous picture plane. And then all these lines converge back to these points. Okay, so I started with the rectangle, and then those parallel lines go to the vanishing point, and I'm going to estimate my depth. This is just, there's no way for me to accurately do this at this moment. Okay, so now you can see from standing, okay, where I can see the top, to crouching down and looking into this object, I can't see the top anymore. So this is consistent with this side view, and this is actually perspective drawing. Alright, if this guy found himself a ladder and he stood on a box way up here, okay, so let's say he climbed up and he just placed the camera up there. So the camera's line of sight is there because I don't want to draw the whole guy here. Okay, so the line of sight would be way up here, alright? And the picture plane is also connected to the camera, so let's do that. I'm going to put the camera or the picture plane a little bit down and put the horizontal line outside of the picture plane. Okay, so we can do this as well. So I'm going to put this high. Nothing else changed. The center point is still there, or this guy didn't move left or right, only up, way up. And then I'm going to start with my rectangle. Alright, so I'm going to trust the grid now. So the only thing that happened was horizontal line went up, and I'm just going to draw my rectangle again. Start with this. Okay, so it's a little bit fatter now, but the same thing applied. Let's make it the correct size. And now, what's the rule? The parallel lines goes to the vanishing point, so that's all I do. That's the only thing I do. Just like before. Don't have to think about extra things. The horizontal line just moved up. And now I'm just going to estimate this depth. Okay, so don't make it there. You'll see if you do the top, you can actually get a bit. Alright, and now you can see this is almost like going for a bird's eye view. Now I'm looking down at this object. Okay, and only thing happened was, think of the web, this moved up, the horizontal line moved up, and everything else stayed the same. Okay, so this is the nice thing about the grids. They're actually there to assist us and help us to draw correctly. Alright, so now the second, or let's do something else with this grid. Okay, so I'm using this 1 point perspective, and I'm actually going through all the things that can happen. So what can still happen with this guy? This guy can actually move to the left or the right. Okay, but when he does that, okay, so let's see what happens when he moves to the left or the right. So 1 point perspective. Okay, so we're still working on a 1 point perspective grid. Okay, this guy moves to the left, and he needs to stay perpendicular to the object. Okay, because this is how 1 point perspective works. So let's say he moves to the left. Alright, so now he's standing here, and he's looking line of sight, parallel, perpendicular to the object. Let's say this is the horizontal line. So the object is there now. This guy has vision rays, so it's still in his line of scope. So how would this picture look like if I look through his eyes? Okay, so we start with the picture plane. Okay, because there's a picture plane and everything else gets recorded on here. So let's just see what happens here. So station point, and he's looking at his vision rays, capture. So here you can see actually quite clearly that you've got a center line going there, okay, to your horizon line, and this image gets recorded on the right hand side, somewhere there. So the vanishing point is on this one. Okay. So this is actually what happened. The vanishing point moved to the left because you moved to the left, but the box stayed in the same place. So now we're going to rely on the box again, or on the perspective grid again to help us. And I'm actually going to draw it on this one because the setup looks quite right. So in the image below we had the vanishing point straight in the center. Now we moved this point, the vanishing point, we moved left, and everything that I just explained, that is what happened. This guy actually moved to the left. Alright, so let's see what happens. Okay, there's my rectangle, there's my vanishing point that shifted. Horizon line is, let's say it was, we're going to use the standard guy here. Okay, it's not the crouched one and it's not the high above one, but you can, obviously you can play around with those settings. I just want to show you guys the convergence. Okay, so point A goes to the vanishing point, point B goes to the vanishing point, and C and D. Then I'm going to estimate my depth. Alright, so let's say it's about this depth, and then I'm just going to connect those back lines. Okay, it's very light, but it's there. It's just, and there's your box. Okay, and the camera moved. If I move this vanishing point more to the left, let's say to the side, so now this guy really moved away. Okay, still his line of sight is going to stay parallel. Right, so you can do a little center vanishing point thing there, but it's not necessary. And then what only thing I do is I focus again on the rectangle and take the points and go back to that vanishing point. And now you will see a lot of distortion, but this is what's happening. So this is why we are going to move eventually to a 2-point perspective, because here we are actually like reaching the limit of a 1-point perspective. So if I do, okay, let's go. Okay. So this doesn't look bad in the sense of distortion, not yet, but it starts to look a little bit strange. So this is when we move to a 2-point perspective. But I just want to show you the dramatic movement here. So this is the side of the box. Okay, ignore the first one. So this is what happens when you move these around. And if you move to the right, then you will obviously see a little bit, you will start seeing the right of this box. Alright, quite easy. And fun. Okay, so now that was that. The next thing that you can also do with this viewer is you can actually tilt the camera. So we added parallel to the ground plane. Okay, so this is just for ease of use of the grids. Okay, so if we keep this line of sight parallel to the ground plane, then our verticals and horizontal lines will stay, listen, parallel to the picture plane. Okay, so the verticals will stay parallel to the picture plane, and the physical horizontal lines, these ones, the physical, will stay parallel to the picture plane. So this just makes it easy. Like remember in the first grid here, it's easy to add these lines because it's not skewed lines or thing. It's parallel lines that I add. So the same goes for 1-point perspective. Okay, and the reason for this is that we keep this camera looking straight ahead. So now we can tilt this head. So this guy looks towards this thing, okay? But think of the web again. If you tilt this camera, things start to happen. So the station point keeps this, it's the same height, nothing changes there. Only the line of sight tilts. Okay. So how would that look? What would happen there? Alright, so usually with this is where you get a 3-point perspective. Okay, then there's a vanishing point that's created way down. Well, it can just be below the horizontal line and above the horizontal line. So I'm going to use. Okay, let's take the 1-point perspective and do it. So then it's not technically a 3-point perspective, but what happens is the vertical lines, okay, now they are not parallel to the picture plane anymore. They converge to a point above and below. Okay, this is the important thing to remember. What happened? You tilted your head, and this is the consequence. Okay, so I'm going to do a horizontal line or a horizon line, a vanishing point. Okay, normal setup, and I'm going to choose the bottom of my box, and now I can't just go parallel up with this line. This line needs to converge to a line below or above. So let's say below, so this means that the guy was looking down. So I'm going to put a vanishing point somewhere here, and then I'm going to go through this point. I'm going to go through this point. Just because it's a grid, I can actually extend beyond, because I just want to use this as construction lines. And then I'm going to put in the height. Okay, now I've got my rectangle, and you can see this dramatic effect that this has. And this is the characteristic about a 3-point perspective, but in this case we have a 1-point perspective with a tilted camera. Okay, so there's a difference. There are some exceptions. Now I'm just going to connect these points like a normal 1-point perspective, find my depth there at the back, and now these lines need to converge to this point again. Now I'm just going to extend them I'm not able to turn my canvas now at this moment, so I'm just going to anyway, so there at the back would be this line. So you can see this dramatic effect of looking down. Okay, and that's what we want. This is the type of thing that we use. And if you actually just constructed this box a little different, and okay, a lot of things changed when I just twisted it around like this, but I just want to show you if the vanishing point would be at the top, it's like looking up. Okay. All right, and that's the basics. That's the basic movements this guy can make. Okay, especially on a 1-point perspective, he can move. Let's think of his movement again. Okay, so this is the station point. So line of sight towards an object. So this guy can move left or right, but just remember, keep his line of sight parallel, and you can move back and forth. That doesn't matter too much. Okay, there's no the object will just get closer, or bigger or smaller. All right, and then this guy can tilt his head up or down. Okay, so that's the basics that we went through. So this is a high horizontal line. Crouch down, oh, and you can go up and down. Did I say that? Can't remember. Anyway, so horizontal line, see the top, he crouched down, looked into this thing, and then he can climbed up to the ladder or placed his camera, and he's now looking like from a bird's eye view down. Horizontal line moved. When we moved the vanishing point left and right, this is actually what happened. This guy moved to the left, okay, and you could see, suddenly we could see more of the box on the side. Where in this one was looking straight ahead, we can only see the bottom, the front and the top. Okay, so now if we start moving this guy to a different place, and this is what we want to do. So eventually we want to move all around, not only in parallel lines and things like that. So now I'm going to put this guy here, and now he's facing this box and he's looking into the corner. All right, So what happened? Okay, a few things. Suddenly his movement changed. This line's not perpendicular anymore to him. These lines, these physical horizontal lines. And if I draw a perpendicular line to his view, just to see, you can see this corner that's been created. These corners. Okay, so now this line actually goes to a right vanishing point, and this line goes to a left vanishing point. Okay, so if this guy is looking straight ahead and he's looking, and the line of sight eventually is the horizon line, this would actually find a point there. Okay, so let's record this on the picture plane, okay, because this is where we want to see this. So how do I find these vanishing points on the picture plane? I'm going to take this side, I'm going to go straight down until I intersect the station point. Same for this, take this side parallel down until I intersect. Okay, so the picture plane, you can see, is perpendicular to my viewer. Here's his head. Alright, so the one vanishing point is perhaps on the picture plane or just misses it, and this is outside of the picture plane. And this is fine. So let's do the picture plane. So I already did a setup here. Picture plane. And the one vanishing point was there, and the one vanishing point was there. It was actually reversed, but it doesn't matter. The distance between these lines are what matters the most. Okay, so I just reversed it around. You see, this one is further apart than that one, so this is okay. Now what I'm going to do is I'm going to just see, I'm looking into the corner of this box. So I moved from here looking straight, now I'm looking into the corner. Right, so instead of starting with rectangle ABCD like I did, I'm going to start with line. Again, this one is AB, but it will be line AC or BD, one of these corners. So I'm starting with the corner. And then I'm going to take this point and this point and connect it to the right vanishing point. Okay, so this is what's happening here. So there's a vanishing point there, and it's a 2-point perspective, 2 vanishing points. And I'm going to connect the top as well. Okay, so now I have these sets of parallel lines, and they all go to the same vanishing point. So it's important to stay in control of your drawing. Okay, these points connect to that side. Now I've got these sets of parallel lines that goes to the left vanishing point, and it's these ones that we are looking at. Okay, now I'm going to estimate my depth, connect the point there, and the same thing, connect to the right. The left is already connected. Okay, let's estimate the depth. This side, there's a point going back to that side, and there at the back they should add up if I didn't miss a point or a space or anything. Okay, this looks a little bit off, but it's okay. So there's the box, and you can clearly see, okay, so what happened was when I swapped these around was that I didn't move to the right, I actually just moved to the left. Okay, so cool effect to see as well. So I was eventually standing here looking straight ahead, and now I move to the left, and now I'm looking into this corner. Okay, so you can see actually how powerful this is already. If I'm going to start to move this horizontal line up and down exactly the same way that I did on the 1-point perspective, then I'm going to have worm's eye view, bird's eye view, and all these types of views and things that I can move around. If I move the left and vanishing point around, you just saw that when I swapped them around actually. So essentially, if this one is a little bit closer here and this one is let's say this one is here and this one is a little bit further, then I'm actually going to move way to the right. Alright, so moving these things around and practicing them is what's going to give you great navigation, great movement on this 2D surface. Alright, so the last one that I wanted to look at, so I'm not going to do different variations of the 2-point perspective and the 3-point, because there's a video that I'm going to do after this, and I'm going to take real life reference, and then I'm going to show you guys more of these grids, again based everything on this. So this is the groundwork that I'm laying down, and then we're going to go a little bit further, and then you'll actually see on real life image photos that I took, the differences, and we're going to look at a duplication method, also cool. Okay, so the 3-point perspective. Okay, so we did cover this a little bit, but this was a 1-point perspective with just another point. It's not called a 2-point perspective then, and it's not really a 3-point perspective. Okay, it's just a 1-point perspective with a guy that tilted the camera. Okay, so in this scenario, it's a 2-point perspective with an added vanishing point, which means we tilted the camera. Okay, same thing. This is the concept now. And then it's a 3-point perspective. So I'm just going to connect all these points. And when you tilt the camera, the most important part is the verticals. Okay, are they converging to the top or the left? If it's the top, I'm looking up. If it's down, I'm looking down. So I'm going to do this guy to the top, just to have a different one. And then what I do is I have to figure out the depth. So on the ground plane, I'm going to estimate a point here, because now I want to go up, and I'm going to estimate the depth that side. So let's connect these, and you can see the only thing that I'm actually doing is I'm just relying on the grid. So I've got the basics, the fundamentals, I know what's happening, I'm understanding the scene, and I'm just connecting points, and I'm designing and actually drawing correctly in perspective. Okay, a lot of distortion at this moment, but the point is this is correct. Okay, so there's my cube looking through a 3-point perspective with a tilted camera. Okay, a little bit up. So this would have been nice if this was a long building, then you would get a really nice effect. Let's connect something up there, you'll see. You can see this massive amount of distance. I connect all the points back to draw through, and suddenly you can see this building. So it's just an added benefit, but way up, and this dramatic effect. Okay, that's 3-point perspective. A little bit it's not difficult to work on this script, but you have to keep track of things, know your convergence, converging lines. So if I add to this, you have to have this natural incline with it for verticals. Okay. Basic rule of 3-point perspective: all physical lines converge to a common vanishing point. Okay, 2-point perspective, all except for the verticals. Okay, so these sets, yes, go to vanishing point, and these sets of parallel lines go to the left, but not the verticals. And on this 1-point perspective, none of the horizontal lines or the vertical lines converge. Okay, only one set of line and the depth. Only one set of parallel lines, and it's the depth that converges to that vanishing point. So that's the difference between all these grids, and how to set them up, and the terminology. Okay, and moving around, thinking about the side views, the top views, and the grids, and where to find these points, and just navigate through the scene. Alright, and if I move one thing, then by looking at these side views and things, or a simple setup, just a top view, simple top view, can actually show me a lot of things and give me a lot of information that I can work with. So I can actually start planning things like, okay, I'm going to set up a camera here, set up a camera close to here, take a little bit back. This is looking straight at the thing, this is looking at the corner. Okay, let's record this on a picture plane. How would that look if I was looking through that camera? Alright, okay guys, I'll see you in the next video. I think that will be a nice video to watch, because it's a little bit more practical. I'll use reference photos that I took of cubes and things, and I'll actually test a duplication technique so that we can prove this, and then I'm going to apply this to design and invention. Alright, thanks for watching, and yes, keep on practicing. Goodbye.